You can do those out of extreme pain.
I like the one he's tearing out his own heart.
Did you get the what? No, that was another class. They didn't laugh near as much as I did. Yes. But then I'd have to like create one that like looked just like you. Yeah, send me a few Bitmojis.
Yes.
Okay.
Can we also do Snoop Dogg and Biggie things that I got to do?
Oh, you want to color by numbers? I can make you guys one. Yeah, yeah.
Color by numbers for us? I would have
I can make you
Cuban.
Yeah. All right. So
Can we do XXX? Can we draw a picture?
now, okay, my hip hop coloring book only has so many people in it, and it's like I'll tell you the options and you guys can choose. Okay, it's a little bit old school, so it's not necessarily like current people who are like famous. You know, it's like a little bit. For instance, my students just colored the Fresh Prince.
Ooh.
AKA
Smith.
Will Smith, thank you. Because Fresh Prince of Bel-Air. Because he had a rapping career back in the day.
He's a song called
Yeah.
Wild Wild.
All right.
I love it. It's a direct rip-off of Stevie Wonder's I
So, Larson, page 178. And we are doing 1 through 13 odd, but we're going to do number 4 instead of number 5. So 1, 3, 4, 7, 9, 11, 13. Okay. So problem number 1 says that the original function, oh yes, come sit. The original function is f of x equals x cubed minus 1. Okay, so on the chart, the first thing they want us to do is find the inverse function.
Switch the x and the y.
So x equals y cubed minus 1. And then solve for y. Plus 1, so x plus 1 equals y cubed. Cube root, so cube root of x plus 1 equals y. And so up here, I'm going to say my inverse function is cube root of x plus 1. Okay, so now we say, all right, our inverse function, are you guys okay with me rewriting that so it's chain rule nicely to the 1/3 exponent? Are we okay with that? Okay, so I have x plus 1 to the 1/3. I need to find the derivative of it. So now I'm going to say f inverse prime of x, because I'm doing the derivative. And I'm doing the chain rule. So I take the 1/3, I move it to the front, keep the inside the same, subtract 1 from the exponent, negative 2/3, multiply by the derivative of the inside,
1, doesn't matter.
and then clean it up a little bit. So I've got 1/3 times the cube root of x plus 1 squared. Okay, so f inverse prime of x is 1/3 cube root x plus 1 squared. Okay. And now it's telling us to evaluate the derivative of the inverse at an x value of the a. And what a did they give us for problem number 1? 26. So now we are going to say f inverse prime of 26. And can I plug in 26, or do I need to go look for the y coordinate?
No, because that's x.
It's in terms of x. And since this is an x value, we can just go ahead and plug in 26 and we're okay. So this is like example number 1 from the video notes, where your problem was in terms of x and they gave you an x to plug in and you just can plug it in. This is not like the other 2 examples where we had to do implicit differentiation and everything was in terms of y. Okay? So this is more straightforward. You do math? Yep. What's the cube root of 27?
3.
3.
27 squared.
I would cube root and then square, if you're doing it in your head. So cube root of 27 is 3. 3 squared is 9. So on the bottom you have 3 times 9.
3 times 9 times 3.
Just a 3 in the front. Yep, so cube root of 27 is 3. 3 squared is 9. And 3 times 9 is 27. So it is 1/27. Well, that was fun. That wasn't too bad. Okay. Do you guys... Okay, since I did number 1 for you, I'm going to ask you to do number 2 real quick. I should have done number 2 as an example, because I just did your easy problem for you, and then we have a more difficult one next. So go ahead and do number 2. You do not have to write it in the chart because there's not room. Oh, sorry. Thank you. Thank you, Alex. Okay, so go ahead and do number 2, and then we will do number 3, because number 3 is going to be one of the more difficult ones. And I want to make sure that we can do those. Tristan, are you distracted by the bright, shiny object? Yeah. Happens.
It's just a crow. It was like silver.
All right, so we're doing number 2. Go ahead and take a moment. Do number 2. This one's a bonus one, so it doesn't go on your worksheet. It just goes on your notebook paper. It's not that bad. It's just kind of like the one from the video.
It is, but that one was ugly too.
I mean, that's kind of hurtful.
The cube root of a fraction is never going to be beautiful.
Okay, so that means I'm doing the right thing.
I mean, who knows? Maybe there's some magic fraction which can pull off that look. But
Definitely not.
Okay, 1 over root.
Did you guys see what I did to make it not a fraction, to make it have fractional coefficients? Rational coefficients? Fractional. That's not a word.
Fractional's a word, isn't it?
I think rational is more
Not math, but
proper.
it's an actual word.
So I went from here to here. I just divided each of them by -2.
Yeah, but you could also just still keep the fraction. And I only have to write one fraction.
But then you have to be careful about your derivative at the inside. It's a little bit easier for us to do that.
Right.
is this what you got for the?
One second, I'm rewriting it.
Okay.
-2.
Super annoying trying to put the inverse notation and the prime notation.
Yeah, I always miss the first parentheses.
Yeah.
Yeah.
Yeah, I always forget that I was trying to put parentheses, try to put the inverse or prime or both at the same time, and then I'm like, oh wait.
Yeah.
I have to. Range.
X over 2 minus 5 over 6. 1/6. No, it's minus. You get -1 over 6 cube root.
Mm-hmm.
For 4, can you just start by taking 127 and putting it over with the x?
Yeah, I probably would do that. I'd probably distribute it.
It was X minus 5.
Yeah, so it'd be 1/27th x to the 5th plus 2/27ths x to the 3rd.
Oh, I mean, that it was 27x.
Yeah. Works out right.
Oh, yeah, you can do that. Mhm.
hour.
Yeah, you can do that. Yep. Absolutely. That actually is probably easier.
5, but yeah, that's the same way. Yeah. I just like to have the x in front.
Yeah.
It's gross to have a 5 into the x. Writing like 5 plus x minus x squared.
Yeah, I normally don't, but I like to, I don't know.
Oh, that's negative.
Sometimes our math textbooks do.
I don't know.
Negative 1 squared, but I still
Yeah,
got it
also they sometimes
right.
start problems with admin, and then add a
Because I got the fraction in this.
Mm-hmm. So you put it back like this, kind of? Huh? Yeah.
I didn't even change 1.5. But then I didn't do anything afterwards. Oh no. It's the exact same thing.
I have negative
Oh, yeah, you can just-
I forgot you can just put it in.
3. It's in terms of how negative x over 2.
I wasn't,
So you get negative 3.5 plus 2.5.
Wait a second.
And then that's this part.
Oh no, I didn't.
Wait, so
Because I didn't do the. I didn't make x into 1/2 x.
Mm-hmm.
yeah, that's
Split it up by
yeah,
x.
and then 1
Uh-huh.
is-
I always do that because it helps me when I do the derivative of the inside to know that that's a coefficient. My brain does not like negative x over 2. My brain does not like that at all. Yeah, quotient rule. Mm-hmm. Yep. 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 How you guys feeling on 2?
I think I did it right.
Good. Okay, can we look at 3? Am I rushing anyone if I do that?
Alex, what number are you on?
I instantly don't like it.
What are you on?
Why?
I did it and it worked, like, I feel like I must have done it wrong because it didn't seem that hard.
If it didn't seem that hard, it might be because I did a good job explaining it.
5 and what? I think 5 yeah, sounds like better than 5.
I've gotten botching since freshman year.
I always call you Alex.
Okay, so
I did something wrong.
if we start number 3, what do we do first? Switch the x and y. Yeah. Can we solve for y? No.
1 over 108 is not 7.
Add 1 to one side, factor out a y, divide by the stuff like.
But then you'd have 2 different y equals, not 1. Yeah. So this right here, that y right there and that y right there are both f inverse of x. They're just not isolated. The f inverse of x is like in the middle of the problem, and there's nothing we can do about it. Okay, so I'm gonna go up here and I'm just gonna write x equals y cubed plus 2y minus 1, and then I'm gonna write that note to myself that that's f inverse of x, and I got nothing. That's all I can do to find the inverse function. Now, for me to do the derivative of something that looks like that, what's my method? Implicit differentiation. Okay, so now I'm going to take x equals y cubed plus 2y minus 1, and I'm going to go ahead and do implicit differentiation, so that x should turn into a 1, okay? Y to the third should be
3y squared dy dx.
3y squared dy dx, 2y
2 dy dx.
2 dy dx minus 0. Okay.
1 over 3y squared plus 2 is equal to 2y dx.
Yeah, that.
So
We need more space than we're given on here to work through some of these problems.
I did all my work on a separate sheet of paper and I just put the answers in the chart.
It says work should be completed on a separate sheet and attached to this worksheet.
So how do I get dy dx by itself after I factor it out? Divide the parentheses. So I've got 1 over 3y squared plus 2 equals dy dx And this right here, since that was f inverse, that means that this dy dx is f inverse prime of x, because dy dx represents the derivative of y, and y is the inverse, and so dy dx is the derivative of the inverse. Okay, so I'm going to go ahead and up here, I'm just going to write dy dx because I'm not sure about writing that other notation. Yeah. Yeah, that's totally fine. No big deal. All right, so here, when they give us an a value, they're really giving us an x value. So they're telling us that f inverse of 2 equals a y coordinate, right? And so that means that the original problem had f of some x coordinate equals 2. So in the inverse problem, they're saying plug in 2 for x, because f inverse prime of x is the notation, so that's an x value. So if we look back at the original equation, that must have been a y. So now I grab my calculator, and I graph x to the third plus 2x minus 1. And then what do I put in for y2? 2. And so that was an x value of 1, which means that for the inverse, it's a y value of 1. And so for me to find f inverse prime of 2, that is exactly the same as me taking dy dx and evaluating it at the point 2, 1. 2 for x, 1 for y. Does that make sense? That is the funkiest part about these problems. Okay, so now I can go ahead and I'll say that I've got 1 over 3 times y squared plus 2, which is?
1 over 5.
1 over 5. Add that to my chart, and I'm good to go. Okay? Sound good? So the plan is we're going to get done through number 9, and then we're going to go back and add that little bit to our notes, that blank space that I had you guys leave last night. Okay? All right. So go ahead and work on that. If you are speedy and you get to number 11, that's totally fine. Okay? If you keep going and you get down there, that's totally fine. Your other option, if you just want to get to 9 and stop, is you could start working on the AP style questions from the implicit differentiation worksheets, because those AP style questions will be homework over the weekend. Okay? Yeah. So we're adding a shortcut. And here is the notation of the shortcut. You start with the original function, f of x equals something, right? And then from that, we find the inverse, and we say that the inverse, we're going to go ahead and call it g of x. So remember when I started the video notes yesterday, I said that this little description, they were telling you if you could find a derivative or not. And they started off with the function f, and then they called the inverse g. Remember how they did that? Yeah. Okay, so we're going to do that. We're going to call the inverse g. The shortcut says that g prime, so if the inverse is g, then that means that g prime is the derivative of the inverse. Okay, g prime is 1 divided by f prime of g of x. That's the shortcut. Okay, so we're saying the inverse is g, and we're saying the shortcut to find the derivative of the inverse is to do 1 divided by f prime of g, and this right here is composition. Composition is when you take one function, you plug another function into it, okay? So what we're going to do is we're going to take some of these example problems and we're going to find the inverse the shortcut way so you can see how it's different, okay? So if we look at this first problem, all we have to do is we have to take the derivative of the original function, and we do 1 over the derivative of the original function, and then we take the inverse that we already found and we plug it in, okay? So go ahead and take your f of x right here. I'm going to say f prime of x. So this is an extra step that we didn't have to do when we did it the long way. Okay? F prime of x is what?
4x.
Just 4x, right? Okay, so the shortcut tells us, now that we know g of x, I'm going to go ahead and write g of x. We found the inverse, right? And the inverse was the square root of x plus 4 over 2. So here's our derivative of the original function. Here's the inverse of the original function. So the shortcut says g prime of x equals 1 over 4, and then I'm plugging the inverse in for x. So the f prime, see that? 1 over f prime? So this is me doing 1 over f prime. Instead of plugging in x, I'm leaving that blank. Do you see that? Okay. Now I'm going to take my inverse and I'm going to plug it in. X plus 4 over 2. Done. Now compare that with the derivative of the inverse that we actually got. Is that the same thing? It's the same thing with less work. You see that? Okay. Now, the thing that I don't love about the derivative of the inverse done this way is that you can sit down and explain how it works, but it's one of those explanations that's really going to mess with your brain until your brain is ready for it. I don't think your brain is ready for it right now. So once we've practiced it a bit, we can really talk about inverses are x's and y's trading, and we can go back and explain why this works. But I think we're going to have to sit with it for a little bit. So one of the reasons I don't love the shortcut right away is I think a lot of students would have a hard time with it. Okay? All right, we're going to try it again. Ready to try it for the next problem? Okay. So I'm going to my next example. I'm going to start up here by finding the derivative. So I'm going to say f prime of x is, and what would I get? 3/4 x squared plus 1, right? Okay. Now, remember how we drew this arrow up here and we said that y is our inverse, right? I'm going to say that y is g of x. So this time, we're just going to plug a y in because that y it's not isolated, right? So I can't plug in a whole chunk. I'm literally just going to plug a y in, okay? So there's my g of x, there's my f prime of x. We got it? My g of x is just a plain old y because it didn't get to be isolated, okay? So now when I say my g prime of x, I'm going to say that's 1 over, and I'm going to do 3/4, leave the x blank, squared plus 1. So I'm leaving that out. And then I go down here and I say my g of x is just a y, and I stick my y in there. And I'm done. Mm-hmm. Because it represents, it's because it represents the whole inverse.
Yeah, because like if you can isolate it, then you can plug in something in terms of x. If you can't, then you just say there's a function here. Remember that there's a function.
And if you look, see how that matches your inverse, but with a lot less work. Okay, let's try it again. Next example. Okay, there's f of x. What's f prime of x? 2 minus sine x. Okay, what's our g of x? It's just y, right? I'm going to point right here. There's my g of x. And so my g prime of x is going to be 1 over 2 minus sine, and I'm leaving a blank where my x was. And then in the blank, I go back and I plug in my g of x, which is y. And I'm done. It's so much easier. And then when we compare, we see it's the same answer. Okay? It always works. That's actually why when you go back to asking if it's differentiable or not, that's why they say f prime of g of x can't equal 0, because then you would have 0 on the bottom of a fraction. Does that make sense? And that's the shortcut, is that goes on the bottom of the fraction, so that's why it can't equal 0. Yeah. Okay, so what I would like for you to do is I want us to go back to this right here. And maybe just next to problem number 1 on your paper, I just want us to go back through and practice that shortcut. So maybe right here I'm going to say f prime of x is 3x squared. And then my g of x is right here. My g of x is right there. And so now I'm going to go ahead and just say g prime of x is 1 over 3x squared. And then inside I can plug in my g of x. And does that match what we got? It does? Okay. Jump down to number 2. F prime of x is negative 6x squared. This right here is my g of x. There's my g of x right there. So now I've got g prime of x is 1 over negative 6x squared. And then inside I've got that cube root of x minus 5 over negative 2. And you can just do it like that, yeah. Okay, let's fix number 3. Okay, so there's f of x. F prime of x is 3x squared plus 2. That y is my g of x. And so g prime of x is 1 over 3 times x squared plus 2. And what do I plug in for x? Y. Isn't that crazy? Okay, so when you guys switch over and start doing AP style problems, this is a major time saver, which is beneficial because on the AP exam it's timed. And you want to make sure you save your time for problems that really are difficult instead of saving your time on something that you could have used a shortcut with. Okay, so I would recommend, if you're going to put only the shortcut on your cheat sheet, that you have lots of really good examples of the shortcut. Does that make sense? Because I think that the long way kind of makes sense. Find the inverse, then find the derivative. That makes sense. I don't know that this shortcut makes a lot of sense, which means you truly have to have it memorized. And if you don't have it memorized, you're done. You can't figure out the problem. Does that make sense? That's why I don't love the shortcut for everything. Okay, what I would like for you to do next is do 11 and 13, and then I'm going to show you a little shortcut with that as well. Okay, so work on 11, work on 13, then we'll shortcut. You'll watch the video to make up the shortcut. And video. Okay, so when we did 11 and 13, I'm just going to write out some information because you did it the long way. You showed all your work. We're going to do it a fast way, okay? So here's the shortcut. I'm looking at 11. So 11 said f of x is x to the third. I would put this on your video notes. So it said f of x is x to the third power, and it told you that if you plug in 1/2 for x, you get 1/8 for y, right? Okay. And so I would go ahead and I would just say f of 1/2 equals 1/8. I'm writing it like that because these are your notes, and this is the least comfortable way I think that you can see it, and so you will see it that way often because it's not as comfortable. Okay. So f prime of x is what? 3x squared.
3x to the second.
Okay. So if we do f prime of 1/2, then what do we get? 3 times 1/2 squared. Oh, that was very painful to hear. 3 times 1/2 times 1/2. I'd be okay with that, but not 3. Not 3/2 times 3/2. And 3/2 times 3/2 is definitely not 6 over something. Okay, so 3/4. Okay. Now, without even knowing what the inverse is, without even finding the inverse, not doing any work, I can go ahead and say f inverse of 1/8 is 1/2. And I can say f inverse prime of 1/8 is 4/3. I do nothing else. They love to give problems like this. They love to give problems where the only information they gave you was an x-coordinate, a y-coordinate, and a slope. Because you can't possibly do it the long way, you have to understand how it works. Does that make sense? They love to give you that. So you have to know that when you do the inverse, that your points get flipped, and that when you do the derivative of the inverse, your slope gets flipped, right? Because this was change in y divided by change in x. So if you trade your x's and your y's, then this would be the new change in y divided by change in x. Okay? They love to give you problems like that. All right? In fact, the AP question on the back of the sheet is a funky version of that type of problem. Okay? They make it so you can't possibly do the inverse by hand. You have to understand how this works. Okay? So let's try it again looking at number 13. Thanks, Tristan. All right, so in 13, f of x is the square root of x minus 4. They told us that f of 5 equals 1. So if we find the derivative of x, we're doing the chain rule, right? So I've got 1/2, keep the inside the same. I've got my exponent of negative 1/2, and then I'm multiplying by the derivative of the inside, which is 1. And so I have 1/2 square root x minus 4. Okay. So the derivative evaluated at 5 is 1/2 times the square root of 5 minus 4, which is 1/2. Okay, so if we want to say that in the original problem, all they told us, this could be an example of a problem. They could say f of 5 equals 1, and they could say f inverse of 5 equals 1/2. You could have a multiple choice problem where that is literally the only information given. They would only give you that. And from that, you would say f inverse of 1 equals 5. and f inverse prime of 1 equals 2 over 1. So with only this information given, you can get here. And you will see problems like that on your problem sets all year, because it's a very common type of problem, little to no work to show, very easy if you know that it works. But if you don't know that it works, you're like, what? There's not enough information. That makes no sense. All right? Yeah. All right.